Here's some more problems that we had questions on the homework. This is section 1.2, number 20, and it says graph. Well, let's see, what does it say here? My book out here. And it says determine, identify the domain and range and draw a graph of the function. And it says you can use your grapher, your calculator. Now, what we can do is, if we're going to sketch this, we do look at this, and you can do a lot analytically rather than getting out your calculator. And sometimes the calculator is a little bit misleading in what you've got. So anything that makes the denominator 0 that won't divide out is going to be a vertical asymptote. And when x is 2, 2 squared is 4, 4 minus 4 is 0, and when x is negative 2, so those are going to be asymptotes. So when x is 2, or when x is negative 2, you're going to have a vertical asymptote. Obviously my scale's not very good, is it? Let's put it over here. This will be even. Should have used a ruler, excuse me. Something like this. So that would be 2 and negative 2. So we know we've got asymptotes there. That means it's going to go up towards infinity. So we want to keep that in mind when we're figuring out the domain and range. Now we can graph this and see what it looks like. It looks like kind of that looks kind of like some part of a circle type. Oops. If we had y equals just that, that would be a circle. So let's see what we've got. Move it like that. There we go. And turn on, go to y. Got something in there, so let's clear that out. And then we'll go back to y1. Okay. And then we'll put in our equation. That's going to be 1 divided by. So I'll put 1. Hit 1. And divide it by. And then I've got the square root. So second x squared is that square root. And 4 minus x squared parentheses. And I'll try zoom 4 because it looks like we got something happening up to 2. So zoom 4. Let's graph this thing. Well, it's an upside down circle. Looks like that, or part of it, or a semicircle. Remember the other one we did was a semicircle. So if we want to find the domain, it looks like it's going to go. And if I sketch it, if I wanted to find the value here, we could go to trace here. And notice when x is 0, it looks like it's symmetrical. It doesn't look like an even function. So when x is 0, it's 0.5, so it looks like it's going to be something like this. Now, you can't tell that there's a vertical asymptote here, because if you just trace over here, notice as you go all the way over here, but at 2, we don't know what it is. And if you go second trace, which is calculate, and you put value in, press enter, and put 2 in, and press enter, you don't get a value. So that's kind of an indication that we do have a undefined pointer or an asymptote. So if I want to draw a sketch of my graph over here, if I call this 1, and this is 0.5, it looks like it's going to be like this, and it looks like it's going to curve like this. And it looks like it's going to be asymptotic, so it looks like it's going to go up. We don't see that on the calculator, but it looks like that's what's happening. But it is equal to 0.5 at x equals 0. So it looks like my domain would be negative 2 to 2, but not equal. So that would be open. That would be my domain. And it looks like my range would go from 0.5 at 0.5, it's equal to 0.5, all the way up to infinity, because it goes all the way up there. Okay? So the calculator kind of helps, but then it's a little misleading, because you might think it just goes up to 4 or something, but it keeps going up because we have asymptotes. So you have to do a little bit of analytical work. All right? Okay, so that's number 20. Then number 50. Well, we want to graph this. Well, this is based on our parent function. The parent function is y equals the square root of x. And we're just going to shift this 4 to the right and down 3. So that's where the vertex of this little v is going to be. Now we know that this is going to be a v. But we have a 2 in front of it, so we have a difference, what we call shape equation. So yx. And we can put some values in here for this shape equation. So this would be the new shape equation would be y equals 2 times the absolute value of x. So let me put some points in here. So when x is 0, y is 0. When x is 1, y is 2. And when x is -1, the absolute value of -1 is 1, and 2 times 1 is 2. So we got a couple points there. And that gives me my shape, and then this determines my shift, so I have a shift. And this means I'm going 4, and it's always the opposite sign here, so this is 4 to the left and down 3. Okay, so let's graph it, and I got some graph paper out because I threw a little graph paper over here so you can see what you do. Now, first of all, you find your vertex. So your vertex is normally 0, 0, but it's shifted 4 to the left and down 3. So I go 4 to the left, 1, 2, 3, 4, and down 3. And there's my vertex. Put that in red. Okay, 4 to the left and down 3. Now this is my shape equation, and I just use my points, 0, 0. And then when x is 1, I go 2 up. And when x is -1, I go 2 up. And that's all I need. And then I just connect that with my trusty straight edge here. Oops. And over here. And there you go. So it looks like that. It's a little skinnier because it's got a shape change with a 2 in front. If that number is bigger than 1, it makes it skinnier. If it's like a fraction, like a 0.5 or 0.3, it gets flatter. Okay, and that's all you have to do for number 50. There's the graph. And, they want us to state the domain, the range. Well, it looks like the range is all real numbers because these go both directions, so the range would be all real numbers. So the range would be -infinity to infinity. And the domain, it looks like I'm starting at -3. And it looks like it's going all the way up also, so it's going to be -3 to infinity. So there's your domain, there's your range, and there's your graph. So I hope that makes sense.